Hello viewers, welcome to Sarifort YouTube channel. Today's topic is logic gates. We use logic gates in computer organization and architecture purpose and for digital electronics purpose. We use logic gates in different cases. We use this in physics and BJT purpose. We use logic gates in many ways. This is the important topic. We have universal logic gates and exclusive logic gates. First type is AND gate. It is a representation of multiplication purpose. When we give any two inputs, the symbol is like a D shape representation of gate, and it will give one output. By multiplying these two A and B inputs, it will produce the A into B output. Multiplying these two inputs is known as AND logic gate. This is a graphical representation. Algebraic function is like x equals to A into B or AB. This is the truth table. A is the input, B is the another input, x is the output. When we give 2 power n inputs, we are giving 2 power 2. A and B are two inputs. This is the formula for calculating the values. 2 power 2. X and Y are two values. So 2 power 2 equals to 4. We will solve it in 4 cases. 0, 0, 0, 1, 1, 0, 1, 1. 0, 0 is a 0 case. 0, 1 is the, simply you can remember like a 2 zeros and 2 ones. 0, 1, 0, 1 alternate. 0 into 0 equals to 0. We will get a 0 output. If we multiply 1 into 0, we will get 0. 1 into 0, we will get 0. 1 into 1 is 1. So in 1 into 1 equals to 1. This is the possibility of getting one output. Remaining all cases as a 0 output. This is a representation of AND with a truth table. This is the OR representation. It is used for add. It is like a taking reverse like a arrow mark curve shape. This is a representation. When we give any two inputs A and B, we will get one output by adding these two, A plus B. Similar to AND gate, but here difference is with output. These are all inputs same for all gates. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. In Boolean values collecting purpose, 1 plus 1 equals to 1, we will get 1. Addition of two numbers, we will get one value. This is the main thing you need to remember. Third type is inverter. It is represented with one input and with a triangle shape. It is represented with a bubble and it will produce one output. When we give A, it will becomes A dash. When we will give Y, it will becomes Y dash. It will give the opposite of that value, input value. X equals to A dash. 0 given means it will produce 1. 1 given means 0. It will produce the opposite symbol of opposite value for the given input. Buffer. It is like when we give input, same output will be produced by buffer. When we give A as input, it will produce A. When we give X as input, it will produce X output. X equals to A. When we give input, that value will produce as output. When we give 0 input, it will produce 0. When we give 1, it will produce 1. When we give 1 input, 2 power 1 is 2. So we will get 2 values. Here also same. When we give 1 input, it will produce 2 values. 2 power n. Here n is the input value 1. So we will get 2 values 0, 0 and 1, 1. NAND. It is a representation of NAND equals to AND plus NOT. AND gate plus NOT gate. NOT gate is nothing but inverter. This one. Adding first type AND gate and third type NOT, we will get the NAND gate. adding these two values. We will take two values. It is similar to up to here. It is similar to AND gate. Here bubble will be extra added. It will represent the opposite value of the given input. For NAND, we will take AND value. First, we will multiply these two inputs and we will produce the NOT value. Opposite for the AND value, we will get the output. 0 into 0 is 0. Opposite of 0 is 1. So, output is 1. 0 into 1 is 0. For 0, opposite value is 1. So, we will get 1 output. 1 into 0 is 0. 0 opposite value is 1. So, we will get 1 output. 1 into 1 is 1. In logic gates, for 1 opposite value is 0. So, this is the representation of NAND gate. NOR gate. It is a representation of NOT plus OR. NOT is the inverter. OR is the addition. These two values together, we will get NOR. It is similar to OR gate. Here extra bubble will be added. It will represent the opposite value after calculating. 0 plus 0 is 0. For 0 opposite value is 1. So we will get 1 value. 1 plus 0 is 1. For 1 opposite value is 0. 0 plus 1 is 1. 1 opposite value is 0. In logic gates, 1 into 1 is 1. Opposite of 1 is 0. So we will get 0 as output. This is a representation of a NOR gate. When coming to exclusive arrow and exclusive NOR, these are exclusive gates. When we give two input values, it will produce the for OR gate similar to OR. Here extra like this symbol is added. After that, taking two inputs and this is a representation of NOR. For NAND, this is a representation. This is a NOR. This is a representation of exclusive NOR. This is a representation of exclusive OR. Exclusive OR is opposite for exclusive NOR. It is a representation of taking the plus and circle symbol. It will produce the A dash B plus AB dash format. When we give A and B as input, after calculating this A exclusive or B, this is the exclusive OR value. We have one formula for exclusive. This is a representation of exclusive. Plus and circle symbol A dash B plus AB dash. Multiplying these two terms and these two terms, after that adding together, we will get the exclusive OR value 0 and 0. We need to calculate it. For example, A exclusive B means A value is 0, B value is 1. We need to assume the values. We have one formula A dash B plus A B dash. When A equals to 0, A dash opposite value of 0 is 1. A dash value is 1. When B equals to 1, B dash value is opposite of 0 is opposite of 1 is 0. B dash value is 0. We need to simply write the values in this formula. A dash value is 1. 1 into B value is 1 plus A value is 0 into B dash value is 0. In logic gates, 1 into 1 is 1 plus 0. We will get the 1 value. And for truth table A, B, we will get the output as X. For 0, 0, first two zeros, after that two ones. 0, 1, 0, 1 alternate. We will get the outputs. For calculating A equals to 0, 1, A equals to 0, B equals to 1, we will get the value 1. We need to calculate for these two this term and this term for this term. When A equals to 0 for this value, for B equals to 0, A dash value is 1, B dash value is 1. We need to Substitute the values in this formula. A dash b plus a b dash. For a dash 1, b value is 0. For a value is 0, b dash value is 1. Multiplying 0 into 1 is 0. 0 plus 0 is equals to 0. For 0, 0 values, we have got the answer as 0. Here 0 will come. For 1, 0, a equals to 1, b equals to 0, a dash value is 0, b dash value is 1. We need to multiply a dash into b. A dash is 0 into b is 0 plus b dash into a. B dash value for a equals to 1, b equals to 0. A dash value is 0. For 1 opposite is 0. For b equals to 0, b dash value is 1. We need to apply these values in a dash b plus b dash a formula. We will get like this. 0 into 0 is 0. 1 into 1 is 1. After adding, we will get 1. For 1 and 0, we have got the value as 1. 1 and 0, we have got the value as 1. For 1 and 1, we need to calculate. A equals to 1, b equals to 1. A dash value is 0. B dash value is also 0. We need to apply a dash b plus a b dash. A dash value is 0 into b is equals to 1 plus a value is 1. B dash value is 0. After multiplying into 0, after multiplying 0 into 1 is 0. So for 1 and 1 value also it is becoming 0. This is the process of calculating exclusive OR. Exclusive NOR. This is another type. It is opposite for exclusive OR value. Simply the diagram is same. Here extra bubble will be added. For exclusive NOR, after writing the value same A exclusive B, for this value whole dash applying means we will get the NOR value, exclusive NOR value. Here input values are same. Here we have got 0. 0 opposite value is 1. Here 1. 1 opposite is 0. Here also 1. 1 opposite is 0. For 0 opposite is 1. So these are the process of calculating logic gates. Please subscribe to Survey for YouTube channel and press the bell icon for the latest updates. Thank you for watching.